Awesome, guys. So now we're going to be looking at factorization. And it says we factorize a set of algebraic terms by expressing them as a product of some of their factors, right? So when we use the distributive law backwards, we are said to be factorizing. So let's just really highlight that again. When we use the distributive law backwards, we are said to be factorizing. Cool? So this is the example here. We have ax plus bx is equal to a plus b in brackets times x, which is equal to x times a plus b, where x and a plus b are said to be factors of ax plus bx. So instead of having the bracket here, guys, and then working it out to get this value here, it's the opposite, where we have the two statements with x included, and we factorize the x out of the equation to get x times a plus b, right? Cool. So we'll have some examples to the right away here. It says use the distributive law to factorize the following, right? There should be a 2 there. Use the distributive law to factorize the following, right? So in this case, we have 6x plus 6y. And what's common about these two variables here? Clearly, it's 6. So 6 can go into 6x and leave x. And 6 can go into 6y, leaving y, right? So we'll factorize it. We did the distributive law backwards, okay? All right, so let's do the same thing here. We know that 5 can go into x, leaving x, and 5 can go into y, leaving y. So the same thing, and those are the answers for these. We did the distributive law backwards, right? Now for this one, we can clearly see that we have a 64a squared, and we have minus 8a. But if you multiply 8a by 8a, right, you actually would get 64a squared. So clearly the factor we want is 8a. We can actually factorize 8a out of this equation, and we would actually get 8a minus 1, and that would give us the solution for this question, right? So the solution for this question is 8a times 8a minus 1. So when you're looking at these statements, guys, you have to really look to see what the factor really is for both algebraic expressions, okay? All right, so in this case, we have a 25x minus 10. So what can go into 25 and what can go into 10? 5 can actually go into 25 and 10. And we're going to end up with 5x minus 2, right? Because minus 2 times 5 would actually give us the 10. All right, pretty simple, right, guys? Okay, so the next one here we'll have a negative 49p squared, and we have plus 7p, right? So this one is actually pretty similar to number 3. If we multiply 7p by 7p, we're actually gonna end up with 49p squared. So we can actually factor out a 7p here, and we'd actually end up with 1. We're gonna put the 1 here representing that 7p minus 7p, because negative 7p times negative 7p times a positive 7p would give us a 49p squared. All right, cool. Now for this one now, we have a negative 64x and we have a negative 16. 16 can actually factor into negative 64 and negative 16, right? So if I actually factor out a negative 16 for this question, I'm actually going to end up with 4x plus 1 inside the bracket. Cool. And that will give me my answer. Okay. Now for this one now, we actually have 3 variables, 1, 2, and 3. And we can all see, if we look at these variables closely, guys, at these algebraic expressions, we can all see that there's a w in each of them, right? So we know we can factor out a w, and we can all see that there are factors of 5 here, 5, 10, and 15, so we know we can factor out a 5. So we're going to do that. So we're going to say 5w, and then we're going to get x here plus 2y minus 3z, and that would give us the answer here. Okay, guys? All right, so pretty much finished with the distributive law and factorization using the distributive law. We're going to move on now to factorizing using the highest common factor. Hey guys, what's up? So today we're going to be looking at factorizing using the highest common factor. And it says here the highest common factor, HCF, of a set of numbers is the highest number. Let's look at that again. The highest number that divides exactly into each of them. Example, the HCF of 3, 18, and 27 is 3 because 3 is the highest number that exactly divides into each of them, right? But guys, we're not really using numbers. Remember that we're in section 6, which is algebra. So we're looking at the highest common factor of a set of algebraic terms. It's the highest expression that is a factor of each of the given terms. So the HCF, when you're using algebra, is obtained by simply taking the lowest power of each quantity that is common to each of the terms and multiplying them all together. Cool? So what do I mean by that? Let's just look at a question right away. Instead of numbers like 3, hold on here. Right, instead of numbers like 3, 18, and 27, we would need to find the highest common factor of algebraic expressions like these. So in this case, we're going to do exactly what it says here. Take the lowest power of each quantity. So we're going to find the lowest power of x. In this case, the lowest power of x, let me just write it, the lowest power of x is equal to x, right? X to the 1, which is this one here. And the lowest power of y, the lowest power of y is equal to this one here, the y squared, right? So to find the HCF, it says multiply them all together, right? Let's read it one more time. The HCF is obtained by simply taking the lowest power of each quantity that is common to each of the terms and multiplying them all together. So the HCF for this algebraic expression is going to be x multiplied by y squared, which is xy squared, and that's the HCF. So let's do another example here, guys. Let's say we have a cubed c squared, a to the 7, c to the 4th. There should be no comma there. Sorry about that. A to the 7, c to the 4th, and we have a to the 4th, c to the 6th, right? How do we find the HCF, guys? The first thing we want to do is we want to find the lowest term for the a's. And if you look at the lowest term for the a's, it's a cubed. And then you're going to multiply it for the lowest terms for the c, which is also c squared. And you're going to say c squared. So the HCF is equal to a cubed c cubed, right? All right, so it's pretty simple now, guys. It's really easy. You just have to look at the terms and look at the lowest one for each term, then multiply them together. Cool? Simple as day, guys. Can't get no easier in a family. See me? All right, so let's move on, and we're gonna do some examples related to the highest common factor. Okay? All right, guys. So we're gonna look at some examples here, and we're gonna find the highest common factor. And of course, the first thing we want to do is we want to find the lowest value for a, right? So the lowest value for a, I'm gonna say a L. The lowest value for a is a squared. Then the lowest value for b is actually b squared. Then the lowest value for c is actually c cubed. And the lowest value for d, as we can see here, guys, there's no d here, right? So it's actually d to the 0, which is equal to 1. That's really the lowest factor for d, because we can't divide, we couldn't just choose d3 because we can't divide d3 into the first one, right? So that one is pretty much out. It's pretty much d to the 0, which is equal to 1, which is the lowest for the d. So the highest common factor is actually equal to a squared times b squared times c cubed. And that's the answer. A squared, b squared, c cubed. Nice. All right. So for the next one here, it's actually, of course, we want to find the lowest for the x. In this case, it's x squared. We want to find the lowest for the y. In this case, it's y cubed. And we want to find the lowest for the z. And in this case, it's the lowest for the z is equal to z to the 4. So we can see that the highest common factor here is actually equal to x squared, y cubed, z to the 4th. Cool? Pretty simple, right guys? Just look for the lowest one and multiply them all. Then for this one here, we'll have some numbers here. So we're going to find the lowest common factor for 5, 10, and 15. And in that case, it's obviously 5. 5 can go into 5, making 1. 5 can go into 10, making 2. And 5 can go into 15, making 3. So we'll do the one with the numbers first. Then the lowest for the x variable is actually x, which is this one here. And the lowest for the y is actually y squared. So we're going to have y squared. So the highest common factor here, guys, is equal to 5xy squared. Cool? All right, so we'll have this last one here. We're going to do the same thing. We're going to look at r, and we're going to find the lowest one for r. And we can clearly see it's r squared. Then we're going to find the lowest one for s. And we can clearly see it's just s, right? S4, S5, and just s. And then we're going to find the lowest for the numbers it's being divided by. And we can clearly see the lowest number out of these three numbers is 3. And we're going to find the lowest among the p's. And the lowest among the p's is actually p, right? So what we're going to do is, guys, is for the one with the denominator, it's actually 1 over p. And this is actually 1 over 3. So we're going to multiply them all out. Remember, these are actually 1 over the 3, right? It's being divided by. So we're going to get r squared multiplied by s multiplied by 1 over p multiplied by 1 over 3. And the HCF, we're actually going to end up with r squared s over 3p. And that's the answer. All right, guys? Cool. So pretty much good now. And we're going to actually look into factorizing using the highest common factor. This was just working out the highest common factor with algebraic expressions so that we wouldn't be confused. Now we're going to factorize using the highest common factor. Okay, guys? That's it. And I'll see you in the next lecture. And remember to do your best, and God will do the rest.